Which of the following gas samples has the smallest volume at 300 Kelvin and 125 torr? A. 1.00 gram of hydrogen, B. 2.00 grams of helium, or C. 2.00 grams of methane. Whenever we deal with quantities pertaining to gases, we can assume that the gas is behaving ideally, unless the question specifies otherwise or if information about deviation from ideal behavior is given. A sample of gas is said to be behaving ideally if it obeys the equation PV equals nRT. This equation is applicable regardless of the nature of the gas. In this equation, N is the number of moles of gas particles in the sample, P is the pressure of the gas sample, V is the volume of the gas sample, T is the absolute temperature of the gas sample. When we say absolute temperature, we mean the temperature in Kelvin. Finally, R is the ideal gas constant, which is the same for all gases, assuming ideal behavior. It is typically given on a test. Let's see how we can apply this equation to our problem. We are being asked to compare the volume of 3 gas samples. Specifically, we are asked to identify the one with the smallest volume. We are also given that all samples are the same temperature and pressure. To figure out the answer to this question, then, we could just calculate the volume. Rearranging the equation, we see that the volume V is equal to number of moles times R times the absolute temperature T divided by the pressure. However, there is a smarter way of figuring out the answer to this question. Since we are given the same temperature and pressure for all 3 choices, the factor R times T over P is the same in all 3 cases. We can see that for as long as we're comparing gas samples at the same temperature and pressure, a sample with more moles will have a larger volume. Therefore, all we have to do is calculate the number of moles for each of 3 choices. The sample with the smallest number of moles will have the smallest volume. By now, you should know how to calculate moles from grams. You essentially divide the mass in grams by the molar mass. In 1.00 grams of H2, there are 0.496 moles of hydrogen. In 2.00 grams of helium, there are 0.500 moles of helium. In 2.00 grams of methane, there are 0.125 moles of methane. Therefore, the correct answer choice is choice C. This sample will have the fewest particles and the smallest volume. This relationship between volume and number of particles is known as Avogadro's law. At the same temperature and pressure, the volume of a gas sample is said to be directly proportional to the number of particles present in the sample.